So we're going to proceed with chapter 25 and talk about the architecture of the galaxy. We're going to start with our initial understandings of the galaxy, how we came to that, and the issues that very early astronomers had in figuring out the structure of the galaxy. So, what does our galaxy look like? If you go outside on a nice, beautiful, clear night with an amateur astronomer, they're going to point up at some portion of the sky and say, "See, there's our Milky Way." And you're going to look up and go, "That's really cool. I don't have any clue what you're talking about." And so, how do we figure out what the galaxy looks like? So, William Herschel, German musician, he was an amateur astronomer, ended up moving to the United States, discovered the planet Uranus, built several large telescopes, made measurements of the sun's motion through space. You notice that amateur astronomers often do a lot more than just go outside and stare at the stars. In this painting, William and his sister are posing as they polish the objective lens for one of those big telescopes. So they worked together and counted the stars in different directions in the sky and decided that the structure of space around us was sort of flattened, that, they could see stars out, but a lot of stars out in a plane, but fewer stars in the other portions of the sky. So this actually is one of the difficulties with figuring out our solar system, our galaxy. Think about being a member of the band on the field for the midtime game, or the midtime show, or a member of the orchestra sitting on the stage, or a person sitting on the basketball court for graduation. You look out and you can see between people, and so you can count approximately the same number of people in every direction, because you can't see through people. And so we can't see through the stars to count the stars in the distance. We also can't see through the dust. Dust gets in our way. Dust is a huge issue in astronomy because it obscures our view. Dust particles are approximately the same size as the wavelength of visible light, and so the light waves run into the dust and they don't make it around. So when we look at the structure of the galaxy, what is it that we do actually see? Well, we in the Milky Way are in a barred spiral galaxy. So there's this central bar in the center, arms extending out from it. We are in the Orion bar, which is a very minor arm. We are about a third of the way out from the edge, from the center of the Milky Way. And the entire Milky Way is about 100,000 light years across. However, it's very flat. If we look edge on, and we're going to be talking about edge on galaxies for a while, we see that the arms are exceedingly flat, only like 2,000 light years across compared to 100,000 light years in diameter. The bulge, which is a little bit fatter than the arms, and then globular clusters out here in the outer edges. We talked about globular clusters a couple of chapters ago, and we will be talking about them again. So, different view, but it helps solidify the understanding of that, structure. So we have the flat disk, the central bulge, and then the halo. And those globular clusters are out here in the halo. So how does one describe the structure of the Milky Way galaxy? If we look back, Harlow Shapley, really interesting guy. He was born in Missouri, quit school with a 5th grade education to help on the farm. 17, he got frustrated because there weren't enough jobs, so he went back to school, finished high school in 2 years, went to college, and ended up in astronomy. But he was studying RR Lyra. They are variable stars, and they're mostly found in globular clusters. We've talked about Cepheid variable stars. This is a different style of star that its brightness varies. So he was mapping globular clusters and mapped 93 different clusters and realized the center of the Milky Way isn't where we thought it was. So how did he do that? Well, if we are driving along in a car and it's a foggy night, really foggy night, you can't see forward, but you can see up. And so we look at trees and buildings and structures up out of the fog in order to navigate and be able to tell where you are. We can do the same thing in the Milky Way. The dust in the disk of the Milky Way and all the stars makes it hard to see where things are. But if we look up at those globular clusters, globular clusters, like everything else, follow Kepler's laws. So if you can observe how it's moving and estimate the period, you can figure out the distance to the center of mass. So with 93 of them, he was able to figure out where the center of the galaxy is. So the stars in the disk basically go around in a nice flat circle, but globular clusters go in every direction. And so having 93 of them said, oh, I found the center of the Milky Way galaxy, and it's not where we thought it was. And so we have, this image of the globular clusters that Harlow Shapley identified with our, Herschel's Milky Way galaxy and the sun identified. And, from that, Shapley was able to say, wow, we are nowhere near the center. So if we look down on the Milky Way galaxy from above, we have this central bar and arms. So we live in a barred spiral galaxy. Next chapter we will be talking about the various different types of galaxies: spiral and barred spiral and elliptical, irregular, and we will look at those. So how do we see into our galaxy when dust gets in the way? So this is an image, this is 3 images of M83. And right over here, this V means that this image is in visible light. So we sort of see the dusty arms where the light from stars is reflecting off the dust and coming to us. In the second image, it is in radio. So very different wavelength of light. But we don't, the dust doesn't give us an issue. Radio can punch through the dust, and so we can see the structure of those arms, because we are observing neutral hydrogen. Neutral hydrogen being one of the main ingredients in star formation. And then the third image is in infrared. In this case, it's near infrared. And so, once again, infrared can punch through the clouds of dust and show us the structure of the galaxy. We get a much better view of the bar in this image than we do in either of the other two. So we'll use lots of different wavelengths to look at structures in space, because each wavelength will give us different information. So the Orion Spur, that's where our star is, and we have several items marked on the location for this star, for this arm. So our sun, Cygnus way over here, the Gum Nebula, the Orion Nebula is very close to our sun, Perseus. Basically, it's just kind of an awesome image of the Orion Spur of our galaxy, our immediate neighborhood. So how do those arms form? Well, spiral arms appear to form from irregular clouds of interstellar material that are stretched out by the fact that the galaxy rotates at different rates. The regions farther from the galactic center take longer to make it around the galaxy because, well, guess what? They are traveling a much longer distance, and so they lag behind the inner regions. So I'm going to pause this recording and finish this chapter on the next recording.